Hi, in this video, we're going to look at selection sort, and I did a little diagram here so you can kind of picture what's going to happen here. So I got a list of numbers, 7 numbers, index 0 through 6. What we want to do is put these in sorted order from lowest to highest. Well, in the selection sort, what it's going to do is it's going to start with the first number and compare it to every number down the list. Each time it looks at them, if a number is greater than the previous one, the previous number that we had as our greater, then it will swap the indexes. So it will look at 5 and 8. 8 is larger, so now 8 becomes the larger number. 8 and 2, 8 stays the same. 8 and 12, 12 is larger, so it becomes a larger number. 12 and 9, 12 is larger. 12 and 3, 12 is larger. 12 and 6, 12 is larger, so now we swap 12 and 6. So after this, then what we're going to see, we'll have 5, 8, 2, then we swap, we have the 6, 9, 3, and 12. Okay. So now this part of the list is sorted. We know that now because that's got the largest number. So then we do it again. And we start with the 5, we compare the 5 and the 8. The 8 is larger, so it becomes our holding number. 8 and 2, 8 is larger. 8 and 6, 8 is larger. 8 and 9, 9 is larger. So now that becomes our larger number. And 9 and 3, 9 is larger. So now we're going to switch the 9 and the 3. So now the 3 goes in here and the 9 moves in. And now we have 9 and 3 is sorted, or 9 and 12 is sorted now. So we're going to do this again. 5 and 8, 8 is larger, so 8 becomes the one we're holding. 8 and 2, 8 is still larger. That should have been a 6 there. 8 and 6, 8 is still larger. 8 and 3, 8 is larger. So now 8 is our larger number, so then we're going to swap these. Have our 5, 3, 2, 6, and then our 8 goes in here. Our 9 was already there, and our 12 is already there. Okay. So now we're going to go back and start over again. 5 and 3, 5 is larger, so it becomes our holding place. 5 and 2, 5 is larger. 5 and 6, 6 is larger. So now 6 becomes our number. We're done because those were already sorted. So now we're going to swap again. And we're going to have 5, 3, 2, and 6. There was a larger one, so we swap it even though it's the larger one there, but we don't know that when we're doing the swapping in the code. The program doesn't know that. So, okay, so we're going to start again. 5 and 3, 5 is larger. 5 and 2, 5 is larger. So we're going to swap the 5 and the 2. So we're going to have our 2, 3, 5, and then the ones that we've already done, 6, 8, 9, and 12. Okay, the program does not know that we're done, okay, so we still have to do it again. So we're going to compare the 2 and the 3. The 3 is larger, the 2 is not, so it doesn't swap, and it runs. We're done with all the rest of them. So then we do the swap, even though it's not swapping. 3, 5, 6, 8, 9, and 12. So now it's sorted. Now, you look at this and you say, oh, well, there's only these here. We got 1, 2, 3, 4, 5, 6 sets here. So it was only 6. It's not very bad on that. But that's not what's happening here. Is you got to remember that for 7 items in here, it's doing n minus 1 comparisons. So it's doing 6 comparisons. Then it's doing 5 minus 1, or 6 sorry, it's doing 7 minus 1, then 6 minus 1, and 5 minus 1, and so on until it gets all the way down to the end here. And so that adds up quite a bit. And what it is that it's a nested for loop, which means that this is O(n) squared on here. So let's go ahead and put the code in, and we'll get started on seeing how this works in code. So I'm going to open up a blank window. So I'm going to open it up from over here. There we go. So we're going to start off with our function selection sort and passing in a list. So we're going to do for fill slot in range, the length of a list, and start from the back end of it, -1, going down until we get to 0, decreasing 1 at a time. Then we're going to set our position of max equal to 0. And then we're going to do our other for loop for location in range. This one's going to go forward, 1, 2, fill slot +1. So in here we're going to check to see if a list location is greater than a list position of max. Then we're going to set position of max equal to location. Okay, so we found one that's greater than our position of the maximum number, and that's why we're going to change it there. And then that's the only thing we're going to do in there. So that means then we're done with both of those, or we're done with the if statement, we're done with the for. So now we do the swap, temp equals a list of fill slot, a list of fill slot is going to be equal to a list of position of max, and then a list of position of max is going to be equal to temp. Okay, so let's go ahead and create a main. So we can test this out. We're going to create a list. We're just going to put numbers in here: 54, 26, 93, 17, 77, 31, 44, 55, and 20. We go ahead and print our A list before we sort it. We're going to do our selection sort A list, and then we're going to print our A list again. So let me get this saved. Oops, wrong place. Oh no, okay, that's the right place there. This is selection sort. .py, and I'll get that saved here, and then we'll run this and see how it works. And there's my first error there. I must have missed getting that equal sign in there. There we go. And my second one. Misspelled selection up here. My typing's not the best in the world. And there is our list unsorted, and then our list sorted. Now, just to prove to you that, so over here a little bit, how inefficient this sorting technique is, we're going to change this a little bit. And I'm going to put in put random in here. And instead of creating this like this, I'm going to delete these numbers out of here and have an empty list. I'm going to do a for loop here for num in range, and I'm going to do this as, let's just do it as 100, okay, just to get started here. I'm going to do then a list dot append num. And then after this, I'm going to do I think it's this way here. Okay, so now we got 100 numbers in here, and let's put another thing in here. Import time. So now what I can do is, I'm not going to print these out because I've got 100 numbers here. I'm going to set start equal to time.time. We're going to run our selection sort and then do end equals time.time. And then so what we're going to print out is and let me change this up here a little bit. We'll use count. I'll use total. And then we'll put total in here. Okay, so this then we can see how long this runs. Okay, so let's run this. And we get time is 0.001. Okay, so that ran pretty fast. Let's take this up to 1,000 numbers. Okay, we'll run it again. Sometimes my touchpad doesn't like to work very well. Now we're up to 0.6. So you can see, and what we can do here is I can do another little for loop here for count in range let's just run this for 5 times, okay? Indent this stuff here. It comes out, there we go. Okay, and then inside here, after we get done running this, I'm going to set total equals total times 10. Okay, so it'll go 100, 1,000, 10,000. Okay, so now let's run it and see how this works. Okay, so the first time was 0.001. That was 100. Next one was 0.0 or 0.1. That was 1,000. But now look, it went up to 8 seconds when we did 10,000. So when we do 100,000, it's going to be quite a bit higher. I'm guessing it's going to be around 16 seconds. See how far I'm off? Well, it's almost 9 seconds, so maybe closer to 18 seconds. if I'm way off, it could be 32. I can't remember if it's goes up 4 times. We'll see here in a second or so. And after this one, I'm going to stop it because the next one's going to take a lot longer to do. This one's taking a lot longer than I thought it was going to do on here, but that's okay. I want to make sure that you see this and can see how inefficient this sorting technique is based on time. So as the number of items in the list expands, so does the time on here. And we should be getting pretty close. You never notice how slow time is at certain points. So for right now, time seems really slow, whereas if I was doing something else, it would be really fast. Got to be getting close to being done here. And in the program, I'm going to skip over here, look at this for a second. In the program, I'm doing all this stuff before I start the time. So the only thing I have in the time running is the selection sort on here. So that way, because this takes a little bit of time in here to build this up, especially when you have the 100,000 numbers. Okay. So 100,000 takes quite a bit of time based on what we're doing here. So I may have to stop it anyway, but you can kind of see, and I like doing this type of test on here because while we have all the numbers between 0 and 99,999, the shuffle mixes them up so they're not sorted in any way. And we're using the same numbers each time through. So that really helps too. Now the order is different. So that's not a perfect way of doing it on here either. So what should be done is once we get this list here, copy that list into another list and then sort it. Okay, and then each time through recopy it. So this stuff here would be done outside. It would be done one time. So this would be done outside the. No, we can't do that. So what I've done before is I've added or created my own list of numbers for 100 and stored them in files, 100, 1,000, 10,000, 100,000, and a million, and put those into files. And then I could call the files and run those so that they, when you run them for different sorting techniques, you're using the same list of numbers in the same order, which makes it better. So I'm going to go ahead and stop this. I really wanted to get that next one up here because it takes a long time to run this, as you can see, but I don't want to keep going in this video. So I'm going to go ahead and stop this, but you can run this and test it out for this and see what you get for 100,000 and how long it takes to do that. You can kind of see it's taking a long time. So anyway, I'm going to stop this one. My next video coming up will be over bubble sort, and there's actually 2 different types of bubble sort that we're going to look at. So hope you got something out of this and you enjoyed it, and I'll see you the next time. Bye.